In this lecture, we want to look at the simulation of microprocessor operation using a software emulator. We are going to use the EMU8086 software emulator. This emulator is used to simulate the operation of the 8086 microprocessor. The emulator allows us to enter an assembly program, assemble the program, and view contents of registers, memory, and ports as the program executes. We can also choose to view the overall results of the program after the program is executed. It also allows us to view the assembled code. So generally, emulators are used for the purpose of learning microprocessors as well as for testing programs during the development of microprocessor-based systems. The EMU8086 installation file is available for download from the internet. I'll ask you to search for it, download, and install onto your machine. What you will get is a trial version with a trial period of 90 days. This means that after the trial period, the emulator may cease to operate. You will then need to buy the full licensed version. When you run the emulator, you will see a number of dialog boxes. Respond accordingly and as relevant until you get this window. The window has menu items that are similar in nature to the menu items that we find on any other computer window. I believe you'll be able to figure a way out to work with the emulator. However, I am going to illustrate the basic operation of the emulator using one or two examples. And the rest of the operations, you should be able to figure them out on your own. Let's look at how we enter an assembly program into the emulator, assemble it, view the assembled code, and emulate program execution. Enter the program shown into your emulator. This is a simple program to illustrate the operation of data transfer, logic, and arithmetic instructions. To assemble the program, click on Compile. A Save dialog box is going to be displayed. Choose a name for the resulting file and click Save. A dialog box of this form is going to be displayed. The dialog box has options that can be selected by clicking on the corresponding button. We want to view the assembled code. So we click on View and select Listing. A notepad file is going to be displayed. The file contains the source code and the corresponding machine code. Column 1, labeled line, contains the line numbers for the instructions in the source file. The second column, labeled LOC for location, contains the addresses at which the machine codes for the corresponding instructions are going to be located. The third column, labeled machine code, contains the machine code for the corresponding instructions. The last column, labeled source, contains the source code for each instruction and in assembly format. Let's go back to the main window. We now want to emulate the execution of the program. Click on Emulate. The emulator window is going to be displayed. The window shows the contents of registers, contents of memory, and the assembly program that we are emulating. The contents of registers and contents of memory may be edited. However, this needs to be done with care. There are two types of emulation: single-step and run. In single-step emulation, the emulator executes the currently highlighted instruction, after which it stops. This allows you to view the contents of registers and memory after execution of each instruction. The run makes the emulator to run the program until the last instruction. This only allows you to view the final contents of registers and memory. Let's go to the single-step emulation. Before we emulate, you need to take note of the contents of registers and memory locations of concern. Click on single-step. The first instruction is executed. As you can see, the contents of CL has changed to 5. Click again on single-step. The second instruction is executed. And as you can see, the contents of AL has changed to 37. Continue clicking until you get to the last instruction. Let's view the contents of memory after execution of the last instruction. To get to the memory location, you need to enter the memory address in the text box at the top of the memory section. The number on the right of the column is the offset. We enter the value contained in BX since the required memory location is pointed to by register BX. The number on the left of the column is the segment selector. We enter the value in DS since we need to access the data segment. Press enter. The required memory location is displayed and highlighted. We can see that it contains the value B6. One thing to note is that the memory address in the memory section is displayed as a physical address. That is the address after the offset has been added to the base address of the segment. Before you proceed to the next section, I recommend you do these questions from chapter 5 and emulate them on the EMU8086 emulator. The EMU8086 has a number of virtual devices to simulate the operation of some peripheral devices. These virtual devices are used to emulate programs for systems that contain peripheral devices. Virtual devices are accessed through the Virtual Devices menu on the Emulator window. Clicking on the Virtual Devices menu item results in listing of the available virtual devices. You can then select the one that you want to use in the emulation. We are going to illustrate the use of virtual devices using simple I/O ports. Click on Virtual Devices and select Simple I/O Test. A window is going to be displayed. From the window, you can see that the Simple I/O Test consists of 2 pairs of ports. The ports are at addresses 110, 111, 112, and 113. The Simple I/O Test consists of 2 sets of text boxes. The first set allows you to enter values so that you change the states of the ports. The second set is used to display the state of the ports. An output box is going to change if you type into the corresponding input box. An output box also changes if the program writes a value to the corresponding port. To understand more on the operation of the simple I/O test, you can try out the program that is shown on the emulator screen. Each virtual device has associated port addresses. Therefore, you must take note of these addresses before you use any given virtual device. To get to know more functionalities of the emulator, you may experiment with menu items on the emulator window as well as on the main window. Try these questions from chapter 5 and simulate them using virtual devices on the EMU 8086 emulator. Remember to change port addresses to suit the virtual port addresses available in the emulator.